All right, let's look at a couple of applications of Maclaurin series to limits. Right, so first one, limit of 1 minus e to the x all over x as x approaches 1. Right, so remember that there's a Maclaurin series for e to the x, which is a summation, and it goes from 0 to infinity, x to the n over n factorial. All right, so let's write down a few terms so that we can see what's going on. All right, so here we have limit as x approaches 0. All right, then we have 1 minus, and we put parentheses. All right, so e to the x is going to be 1 plus x over 1 factorial plus x squared over 2 factorial plus x cubed over 3 factorial and so on, right? And then you're going to divide the whole thing by x. Right? So first thing we can do is there's a 1 here minus 1, so we can definitely cancel that out. All right, then we would let's see, we have to distribute this negative sign to each term in here, so all these terms are going to be negative there. It has a negative sign in front. All right, so you just do that. All right, then you divide by x. All right, so if you simplify that, you're going to get the limit as x approaches 0. All right, so you have a negative x divided by x, so it's going to be negative 1. All right, it's negative x squared over 2 factorial is divided by x would be negative x over 2 factorial. And it's going to be negative x cubed over 3 factorial divided by x, so it's going to be x squared over 3 factorial, and so on. Right? But 0 is approaching 0. X is approaching 0. So therefore, starting from the second term, so this guy approaches 0. All right, third term approaches 0. And as you can see that all the rest of the terms are going to go to 0. All right, so you can see that what's left is going to be just first negative 1 here. All right, so that is the limit of the first example here. All right, so let's do the same thing with the second limit. Limit sine of x minus x over x cubed as x approaches 0. All right, so we have the Maclaurin series for sine, so we're going to use that. So this is going to be equal to, let's see, is equal to limit as x approaches 0. All right, sine of x, remember that the sine is an odd function, so you're going to have all the terms with odd powers. All right, so it's going to be x, right? Sine alternates, so its next one is going to be negative. All powers, so x cubed over 3 factorial. And next one is a plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial and plus and so on. Right? Then we're going to have to subtract x and divide through by x cubed. Right? So first thing we can do is, again, you have a x here minus x, so you can cancel those. Right? Then we just need to divide those guys by x cubed. So this is going to give us a limit as x approaches 0. All right, so you have a negative x cubed over 3 factorial would be negative 1 over 3 factorial. All right, next would be plus x to the 5th over 5 factorial divided by x cubed. So that's going to be x squared over 5 factorial. Next one is going to be x to the 7 over 7 factorial divided by x cubed, so x to the 4th over 7 factorial, right? And so on, right? And as x approaches 0, we can see that starting from the second term, just like the first example, these are all approaching 0 because it has x in it, so the rest of the terms are going to go to 0 too, right? So therefore, the limit is going to be negative 1 over 3 factorial is 3 times 2 times 1, so it's going to be 6, right? So you can see that the limit is negative 1 over 6, right? That's it. I hope that this was clear.